In this video, we're going to talk about how to factor polynomials from section 10.6, but we're specifically going to talk about factoring out a GCF, or what to do with a GCF. So the first thing you want to do anytime you're factoring is, I would recommend doing this in the first step and always checking it in the last step as well, is to divide out or factor out any common factors. I think it makes your factoring job a little bit easier if you can do it before you factor, because you'll have smaller numbers that you'll be working with. So when I look at this first example, 5v squared minus 30v plus 40, 5 times 40 is a big number. So when I think of the factors of 200, and what factors of positive 200 that add up to be negative 30, that could be a time-consuming task. Not impossible, you could do it, but if I can factor out a greatest common factor, it'll make my job a little bit easier. So looking at 5, negative 30, and 40, I know that my greatest common factor is 5. So I'm going to go ahead and divide my 5 out. So I'm going to end up with 5 times v squared minus 6v plus 8. So hopefully you can see that if I go ahead and distribute the 5, I will have the original trinomial, 5v squared minus 30v plus 40. Now I can go ahead and factor v squared minus 6v plus 8, but I can't forget about this 5 that's hanging here out front. Now the neat thing about this problem is because I have a value of 1 for a, makes my job a little bit easier when I'm factoring. So I can think of the factors of positive 8 that add up to be negative 6. And when I think of those factors, I think of negative 4 and negative 2. So I can factor this into v minus 2 times v minus 4. And again, I can go ahead and double check my work by foiling my two binomials, that would be these two here, and then distributing the 5. If I get my original problem or my original trinomial here, I know I did it correctly. So here is my final answer. The only other thing I want to check for is I want to make sure that I don't have any common factors left in my two binomials. If I do, I need to factor them out. And since I don't, I know my answer is complete and done. Here's my next example. I need to factor 10x squared plus 25x plus negative 90. So this problem, if I go to start factoring it right away using my factoring using the distributive property or using the grouping method, tells me I have to multiply 10 times negative 90. That's negative 900. So for me to think of the factors of negative 900 that add up to be 25, that could be a lengthy and time-consuming process. So to shorten that work, I can think of a greatest common factor. Now sometimes that doesn't always happen, but in this particular case, I know that I've got the number 5, which goes into all three values. So I'm going to factor or divide out a 5. So if I factor 5 out, I'll be left with 2x squared plus 5x plus negative 18, or you could put minus 18. Now to factor from here, I need to see if I can factor 2x squared plus 5x plus negative 18. So if you think back to section 10.6, to start that process, I need to multiply 2 times negative 18. So multiply a times c. And that's going to give me negative 36. So I need to think of the factors that multiply together to give me negative 36, but add to give me positive 5. And those numbers are, let's see here, 9 and negative 4. So when I multiply them out, I get negative 36. But when I add them, I get positive 5. So what I'm going to do now is I'm going to go ahead and factor this using the grouping method. I'm not going to forget about the 5. I'm going to rewrite it out here, but it's not mathematically going to do a whole lot for my problem other than I'm just going to have to remember to keep writing it. So to factor using grouping, I rewrite my original problem here. Instead of writing 5x, I'm going to put minus 4x plus 9x plus negative 18. Now don't get confused here because in a second I'm going to have a double set of parentheses. So one more thing I just want to point out here is if I were to simplify this polynomial, it would simplify to be this trinomial because negative 4x plus 9x is going to give me 5x. So those terms would combine. So I'm going to go ahead and factor using the grouping method or the distributive property method, whichever one it is that you prefer calling it. So that means I'm going to put parentheses around my first two terms and parentheses around my second terms. I'm going to factor out my greatest common factor. Okay, so I'm going to keep bringing my 5 down here. So let's see here. I'm going to write a 5. And then my new greatest common factor for my first term here is going to be 2x. When I factor out a 2x out of this binomial here, I'm going to be left with x minus 2. Okay, now I'm going to turn my attention to this binomial, factor out a greatest common factor, which in this case is going to be 9. When I take the 9 out, I'm going to be left with x minus 2. All right, I'm going to close the second set of parentheses up here, and now I'm going to put my work together. So this 5 is just going to come down, and I'm going to turn my binomial, my binomials here into 2x plus 9 times x minus 2. Okay, I want to do one more double check to make sure if I have any greatest common factors here, which I don't. Check here to see if I have greatest common factors. And then lastly, I want to check to see if I have a difference of squares. So here I have a difference, but x is not a perfect square, neither is 2, so I can't factor this anymore. So I'm done. This is my final answer. 5 times 2x plus 9 times x minus 2.